Hello and welcome to our webinar on the integrated planning process. Thanks very much for joining us. I'm Kien Leong.
I'm Tony Rice.
And we're going to walk you through a process that we've discovered for joining up planning, all the way from demand planning and the forecast, right the way through to execution with the production schedule and purchasing. So let's have a look at the agenda for the next hour. We're going to start with a few words on who we are and what we do. I know many of you are familiar with us at productionscheduling.com, but maybe some aren't. So we'll give you a bit of background to the two of us and where we're coming from. And then we'll step quite quickly into, first of all, what is the opposite of integrated planning? For want of a better term, disintegrated planning. We won't spend a lot of time on the problem or the current situation. We'll just really have a description so we can have a bit of a baseline and talk to you about some of the problems that we see when planning is not joined up. So within 10 minutes, we want to be getting to the substance of this webinar, which is the integrated planning process. And the integrated planning process is going to be an end-to-end look. So we'll look at the whole end-to-end process and then take each of the steps of the process. We still don't have enough time in the hour for a deep dive. So it will be quite an overview of each of the process. And in order to give us some structure, we'll look at the inputs, the process logic, the outputs, and then we'll show you some examples of how this process might be managed using an Excel-based system. So we've got some screenshots from the Excel system, and we've got the system here on my computer. So if you have any questions about particular parts, then we can look into that. Then we'll go to what to do next. Okay, what you can do to get this working for you, and then we'll have a Q&A in the chat box. Great to see lots of comments there. Thanks very much for interacting. Feel free to continue using the chat and also use that chat box for the questions that you have. We'll try and accommodate the questions as we talk. If we're on the right subject, it makes sense to cover it there and then. But we are also aiming to leave some time for Q&A at the end of the session. So about 10 minutes or so for Q&A. And if we don't get your question answered, we'll do our best to answer all questions. But the last session, we had some really great questions that we want to go into a lot more detail into the answers. So we're going to be holding a separate Q&A session, which we'll tell you a little bit more about towards the end of this webinar. Okay.
Kien, there's a couple of points been raised. One question is this live? I can say, yes, it is. and is it being recorded, and will a recording be available to all the delegates at the end?
Yes,
the answer to that is also yes.
Yeah, it's being recorded. The email will go straight out, and yeah, you'll be able to watch it again, within half an hour or so of this webinar finishing.
Good.
Okay, right. So let's jump in. Let's get started with who we are, and maybe Tony, you can kick us off.
Right. Right, I'm Tony Rice. I launched this website in the year 2000, so that's 20 years ago. I'm a supply chain person. I do impertinent things with Excel, and I was driven to head in that direction through a sense of frustration of trying to get workable IT solutions to supply chain problems quickly and at a reasonable cost. So that's been the reason for heading in this direction. Kien?
Great, thank you. Well, I'm Kien Leong. I'm a management consultant, and I work with manufacturing companies with a focus on operations management. So I've been doing that for 17 years. I've been working with Tony for the last 10. In fact, this month was my 10th anniversary working with productionscheduling.com. Here on the website, we're looking to use this for really sharing some of the ideas and techniques that we have for planning and scheduling using spreadsheets. There's a good amount of content on the site. We haven't actually been very active recently in putting stuff up. So This is to let you know that this webinar is part of a new push. A lot new content is going to be going up on the site, and we'll be sharing more downloads, tips, techniques, doing videos, and putting together webinars like this. So if you have any anything that you see that you want to hear more of, or any feedback that you think might be helpful for us to develop some more content to provide, then let us know in the chat or by email afterwards. Okay, right. So that's enough about us. Let's have a look at what we see as being, first of all, the alternative to integrated planning. Let's call that disintegrated planning or separated planning. And this is a pretty typical picture of what we see going on in most manufacturing companies. I would say pretty much every company that's manufacturing would have the essence of the processes that you see here. It may be formalized, it may be informal, it may be using a software system to do it, it may be manual, it may be good, it may be bad, but there's something going on in all of these process steps. And the problem that we see is that these processes are being done in different places, by different people, and on different cycles of time. Sure, there is going to be some commonality in the people, so the same different teams, but you might have the same sort of people crossing across the different processes, so there's linkages that way. On the slide, you'll see some of the outputs of these processes are inputs of the next process, so there is some linkage from the inputs and outputs as well, but there's a lot of opportunities for misalignment. I suppose the main effort to bring all of the planning together on the demand and supply side is that S&OP, sales and operations planning block there. And, you know, in many companies that does a pretty good job of bringing the planning together, but it still has a fundamental problem in that it's organized on a monthly cycle. And there's a couple of reasons why we think that having a rigid planning process aligned on a monthly cycle might not actually be a good representation of demand and how to deal with it. So let's have a look at what we might characterize as being a traditional view of demand.
Right. A lot of processes we look at seem to perceive time as belonging in big monthly chunks. And typically, this is the view that a lot of people have. There's July's demand being worked on and delivered to customers. Meanwhile, in the background, there's the next month's demand in a big monolithic block, and that's being measured up by the planners who are working out what capacity and what materials do we need to handle this block of demand. And then way in the background, you've got the next month's demand being lowered down onto the rails with a crane. So that is a very traditional view that you'll find in a lot of people's heads and embedded in a lot of traditional planning systems. However, we believe that there's now behind this is a whole preoccupation with months. Now, way back in the dim and distant past, I used to be an accountant, and I can understand that accountants are preoccupied with months. It's the traditional period of time for doing management reporting. But if you look up the word month in a dictionary, you'll find that it is the period of time that it takes for the moon to revolve around the Earth. Now, there's another definition. The word lunar relates to the motion of the moon around the Earth. And there's another word, lunatic, basically, which describes people who are preoccupied with months and the motion of the moon. So this is a cynical view, basically, of months. And we're saying, look, we understand accounting people use months, but a lot of supply chain people have followed the same habit of having their thinking locked into monthly buckets. And there's no need to do that. If you're in a supply chain environment, a month is a bit of an artificial period of time, actually.
Great. Okay. So
a
little delay on the slides, but go on.
Sorry, yeah, a more realistic view of demand, and the way we've the picture we have in our head of this is the pattern of demand that we need to construct our systems to cope with, is that time doesn't fall neatly into buckets. It's a continuum, and you can perceive demand as a big shoal of fish swimming towards you. And if you fix your eye on an individual fish, you'll find that some fish swim faster than others, some are bigger than others, some swim towards you, will stop, hesitate, turn around and swim off, and then you never see them again. And that's basically the pattern of demand that our systems are designed to cope with. It's continuously moving, it's continuously changing. And really just taking a look at it once a month is not good enough.
Okay, so that's the fundamental concept behind our process. Here it is, the integrated planning process end to end. It's not revolutionary. So a lot of the process steps that you see, the words that we're using to describe what's going on at each of those steps will be familiar to you. We're not totally blowing up the planning process and starting again from scratch and bringing in wild and exotic ideas. The main difference is that rather than doing each of these steps on a different cycle with different people in different places, we're connecting it all together and doing it continuously in a flow. So take the process step that is probably using the minimum cycle. You know, let's say if you're taking the production schedule and firming that up and releasing it daily, then we'd be doing this process daily. We'd be taking updates, any additional updates to the market intelligence, small changes to the sales history, regenerating a forecast, all the way through to executing new purchase orders and releasing product to the shop floor. So it's at this point when we're explaining it that planners start to get an anxious look into their face, and they think, well, you know, all of the things that we're doing monthly, all of those meetings, all of that information gathering, all of those data processing tasks and the reporting, we do that monthly, and now you're expecting us to do that daily? Well, no, we're not. The way that we can do this on a near real time, or however close to daily or real time that you need, is because we're automating a lot of these processes. So rather than having somebody through meetings, discussions, manually making decisions about what that plan is, all the way through the demand, from the demand plan out to purchasing and production execution, we're putting in place a system to do those calculations automatically based on some simple rules, logic, and parameters that we can feed into the system. So it's the planners that are spending a little bit more time looking at how this process is performing rather than performing the process themselves. And it allows us to rapidly improve the speed at which we can respond to events. And rather than waiting for the next monthly meeting to come up, we can feed that new intelligence about what's going on straight into the process and do it and get the benefit from that in the decisions that we're making today and tomorrow. Now, does this mean that we need to make this work? You need to do it daily? Well, no. This is a process that is going to work for you according to the business that you run. So, you know, hey, we have some customers who run this every hour. We might have some clients who only do it every few days. Maybe, Tony, you can speak to a couple of examples.
Well, yes. Daily is very common. We have clients that the system reruns automatically 3 times a day. We use very simple technology to automate the run process. We use a Microsoft Task Scheduler, and that works very well. I do have one client that's using just the finite scheduling end of this thing, and that reruns every 30 seconds in response to what's happening on the shop floor. So yeah, it depends on what kind of business you're involved in, the frequency that that you're attempting to aim at.
Yeah. And we've built a demonstration model of how these calculations work, and you'll get a glimpse of that as we look at the inputs, process, and outputs. We're going to go into each of these steps, and we'll use that system as the example for how it will work together. So this is a standard make to stock environment. So we've got finished product inventory. We're receiving sales orders, of course. We're placing purchase orders. We're releasing work orders, and we have finished goods stock together with inventory of semi-finished and raw materials. So that's the kind of model that we're going to pick. There's nothing that's very industry specific here, and what we have has been working for companies that range from 30 to 30,000 people. So, there's a pretty big, broad range of size of organizations. So we've tried to come up with a model that is representative to as many cases as possible. And then we'll point out where the customization or certain things need to be configured for a particular manufacturing environment. Okay, so on to the process then. So the first step in that process is sales forecasting. The inputs of the sales forecasting is demand history. So it's the sales history is a key input because this is a very simple forecasting model. It's going to generate something that's based on both the trend and the seasonality patterns that we find within the demand history. So if we look at this input here, the seasonality inputs, prior to setting this up, we've gone through the item master and grouped the finished products into seasonality groups. So if we believe that we've got a set of SKUs or a set of item codes that behave in a similar way according to the months in the year, of their distribution of demand over the year, then that gives us a total seasonality group. And then we're using that to take the sales history for any given item, understand what part of that is likely to be a seasonal trend, what part of that is an underlying growth or decline trend, and then being able to apply a projection to the growth or decline, and then putting the seasonality back on top. So it's really a simple way of being able to project a forecast in the future. But of course, we want to be giving space for more intelligence and the knowledge and understanding that sales and everybody else might have with what's happening at the customer end of the market. So we'd here have the forecast being presented, the current forecast, last year and the year before, and then giving a chance for the people involved in the demand planning and forecasting process to override that and to update those numbers accordingly. Again, this isn't something that would necessarily run every day. In fact, in our system, it's not even part of the daily run that would tie it together with the scheduling pieces. But it's something that can be run as and when required in order to generate the to take advantage of the fresh information that's coming.
Yeah, our philosophy is, traditionally you'll have forecasting cycles that every month, hurry, the deadline is coming, get your forecast in. We're saying no. If you have a piece of market intelligence, something that's or you have a good idea that the sales of a particular item are going to increase or decrease, or customer's going to place a big order or something, for goodness sake, get onto a computer and tell it about it as soon as you know it. And then the system will respond right away to something you know about the market.
Yeah.
So don't wait for a cycle, do it now. And if you remain silent, by the way, if you have no market intelligence, then the system is going to say, okay, I've calculated an automatic forecast for you based on a fairly simplistic kind of algorithm. And if you remain silent, I'm going to assume that our best guess at the forecast, our best guess at future demand is what the system's calculated.
Okay, so here we've got the output to this whole process is a forecast generated by month, based on history, taking those simple rules into account, together with any updated intelligence that comes from the customer or from the sales team.
We have quite a few clients who've invested in much more grown-up, smarter forecasting tools, and we're more than happy to take the output from a forecasting tool that you may already have in place as an input into the system. But we're saying if you don't have a forecasting tool, here's one that we can plug in to fill the gap.
Right. Okay, so next step along the process is forecast consumption. So forecast consumption is taking the output of the forecasting process, which is the forecast by month. It's also taking sales orders and then combining those two together to be able to consume the forecast and calculate total demand. If we've got a picture of total demand, it's going to be a mix of sales orders and what we might call an unconsumed forecast. And the nearby, the immediate weeks are typically going to be dominated by the sales orders. Anything within the customer lead time, you're probably going to be making demand that's matched up quite closely to sales orders. Outside the lead time, way out into the future, then there's going to be more of that total demand made up with forecast instead. So this is a way, just by using simple rules of how we interpret the situation for any given week, where sales order volume is different to the forecast volume for any given item, and telling the process some simple rules for being able to combine them, and then taking that monthly forecast and the sales orders and now converting it into weekly product demand. And converting monthly to weekly is not just a case of dividing by 4.3 or however many weeks happen to be in that month. One of the inputs to forecast consumption is this distribution. So it's the spread of demand across a month. Here we're looking at 31 days within the month, and it's showing all of the ratio of demand from one being the typical of the average out to, in this case, getting up to 1.2 towards the 26th, 27th of the month. And then with a separate distribution curve for December, because for most markets, the December patterns tend to be a little different. So this is a more intelligent way of being able to take a monthly volume and divide it into weeks, given the fact that there may be a hockey stick effect right at the end of the month, and demand should be higher then. So output of forecast consumption is product demand by the week. So this is now telling us the total demand that we expect to see for all of the weeks going out into the future. Tony, any comments on that?
Yeah, having rubbished the concept of months, we've said, well, here's our forecasting tool, and it works in monthly buckets. So we've kind of contradicted ourselves there. But typically, we do have a weekly version of this forecasting tool, and some of our clients are very happy to use 52 weeks in the year to construct their forecasts. But typically, demand history and the forecasting process, typically people are comfortable with months. However, for planning purposes, weeks are a much better period for planning generally, because they're the same size. Months are not. And in chopping up the months into weeks, as Kian was saying, we could have a situation where here is a week. It actually consists of 4 days of this month and 3 days of the following month put together. There may be sales holidays, public holidays in a month, and the way that the monthly forecast is chopped up into weeks also respects that sort of thing. Okay.
So forecast consumption, outputting total product demand by the week. So just a little refresher of where we are. So we've taken the forecasting process. We've generated a forecast. We've come through forecast consumption to generate product demand. Next, we're into product replenishment. So product replenishment is the last step within our sort of block of distribution. So if you don't make anything, then this is what is going to tell you all about managing the finished goods stock. And one of those three questions that we want to be answering about planning, which is where, what, how many, and when are we going to send finished products from one place to another. So let's have a look at product replenishment. Product replenishment is taking some min-max targets that we express in weeks and comparing it against the product demand to calculate future replenishments. So the inputs are going to be the product demand by week that's come from forecast consumption, the inventory of finished products, so we have an understanding of what we've got in stock, and then the replenishment parameters. Let's have a little look at the replenishment parameters. So you can see some of the settings that we're going to be putting in that are going to be really critical to how effective finished goods stock is at buffering uncertainty and providing availability for the customer. So here we've got all of the different item codes, and we're categorizing or allocating them a min in weeks and a max in weeks, to get together with, you know, some batch and run quantities, and maybe some override for particular customers who expect us to keep a certain number of finished goods units in stock. Now, when we talk about min-max targets or stock targets in days or weeks, there's a critical question here is, well, how do we define a week? What is a week? You can't go to the supplier and order a week of parts. They need a unit of measure in the purchase order. So what do we mean by a week? Well, in many cases, the answer is, well, we take the demand for the last 12 months, we create an average, and that gives us a value that we use to convert a week with a unit of measure. And that often doesn't change very much. If you're taking a weekly average, if you're taking the average week of a 12-month period, then there's going to be a lot of dampening in that value, and it's not going to respond very well. When we say weeks, what we're looking for is an actual calculation of how long that inventory will last based on future demand. So if we've got 2 weeks of inventory and we're increasing that to 3, we're not just adding 50%, we're looking at what the demand is in that 3rd week, and calculating that as being the quantity. So we can be confident that if we have 3 weeks of stock and demand turns out the way we've predicted, then that stock will last exactly 3 weeks, not based on an average of how long it might have lasted in the history. So the output of this, I mean, here's the process in a picture. You can see the max stock, the blue line, the min or the safety stock, the yellow line. And in this example, you can see we've started off with a big overstock within this particular item. So this stock is gradually running down through January through to April. And then we start to see that this projection is now managing it within the boundaries of min-max. And this is a projection. We'd want to then monitor the actuals, and over a cycle that makes sense, have a look at the performance of that item, and then adjust our min-maxes accordingly. So that's really one of the key parameters that planners can be spending more of their time doing, rather than putting a lot of work into a weekly cycle of deciding how many items should be in the finished goods supply chain. So, Tony, product replenishment.
Yeah, I think you've covered it there. Yeah, I've got no more to add for that.
Okay,
Yep.
great. So let's move on to MRP multi-level. MRP multi-level is a pretty straightforward process. This is MRP1, Material Requirements Planning. And we're calculating this at every level of the bill of materials. Anyone who's familiar with MRP will understand the gross to net requirements calculation. So the gross demand comes from the product demand that we've just talked about, exploded through the bill of materials. At each level, we're netting off inventory of semi-finished items or WIP, and then calculating the net requirements for each level of the BOM. And this process is verified and works up to 20 levels. After 20 levels in the bill of material, there is a check just to make sure that we really do need that 21st level and there isn't circular logic at play. The reason we've chosen 20 levels is quite simply it's substantially more than the largest BOM that we've ever seen. I think that's 13 levels, Tony?
Yeah, that was a military helicopter that we've used this system on, and it works just fine. Yeah. Yes, we've used, in fact, a couple of big companies have used the BOM processor to check for circular logic in their bombs, and exactly that. If we're still exploding after 20 levels, then there's something wrong. So we've put together a version of our MRP processor that is not designed to do MRP, but it's designed to point to where the problems are in the BOM before that BOM is then fed into a big crunching MRP system. What amuses me, I'm old enough to remember MRP runs that used to take 17 hours and you did them once a week over the weekend. The fact that we're doing exactly the same thing on a PC in a few seconds still gives me a great source of delight.
And here's a question, Tony, from Marcel. Do we take production yield into account in the BOM setup?
Good question. And generally, in the early stages of conditioning our data before we feed it in, is yes, we do. If there's a scrap factor or a yield factor, what we need to do is to adjust the quantity per in the BOM to compensate for that.
Great. Okay. So output of MRP multi-level is a list of the items that we need to make and the items that we need to buy. And this is the point at which our process branches. So we've got a branch that's taking this output into purchasing, and another branch that's going into the things that we need to make in capacity and production. But before we hand over the things to buy to the buyers to make those orders, the first step is to let's have a bit of a deeper look as to the items that we have in stock. And the inventory cover process is taking the inventory and presenting it in a view against cover categories. So it's looking at each of the items, looking at what sort of cover that item provides against future demand. So this is not the history of how long that item has been in stock, but more relevantly, how long we expect that item to be in stock based on future demand. And here's a distribution all the way from category B, the items where we expect to have no more than 0 to 2 weeks of stock for those items, right the way through to the items that we have in stock where there's no actual demand in the picture at all. And sorry,
very often in early stages of implementation, this analysis is pretty useful for pointing out bad data, basically. Very often what will happen is we'll pick up some examples of here's an item that we have more than 3 years worth of cover, and we're purchasing some more as well. So you go to the buyer and say, excuse me, we've got enough to last 3 years, plus you've just placed an order to order some more. What is the story? Yes, well, the buyer says is, no, we use this stuff all the time. And I say, well, look at the bill of materials. Not according to the bill of materials, we don't. So it's those sort of issues come bubbling to the surface when through the initial cut and probe into this sort of analysis.
Yeah, and over time, I suppose, Tony, we'd want to be developing confidence in the data that's feeding this. I know, and it's some demand data, some inventory data, and then once we have the confidence, it would be looking to shape that distribution into something that looks like the distribution that we'd see in a healthy business where inventory is turning correctly. Any of you out there who've come across DDMRP and even just heard the initial overview discussions will be quite familiar with this diagram down on the bottom here. For many businesses, if we were to do this kind of analysis on their inventory, we'd find that there's a lot of the items where there's too little cover. So the cover categories that are much really shorter than we'd like, leading to risks of shortage. And then a lot of items over here where we have too much cover. And for the ones in the middle, there's a bit of a trough. The DDMRP people call this like a double humped camel, a dromedary camel. And we want to sort of shape this and move it towards this kind of distribution here, where we've got most of the items and the value of the stock in the cover categories where it's turning fast enough in order to keep working capital working, but it's providing the right amount of availability and buffering the uncertainty that we see within the demand. So yeah, inventory cover is giving a up-to-the-minute view of how well our current inventory is performing. And we want to be presenting that to the buyers before they're making any purchasing decisions about what to add to that inventory. Okay, so the output to this is just a simple report, inventory cover. So now we've got a purchasing module. We're taking the input, which is from MLP, the things that we need to buy. We're also looking at the outstanding POs. Of course, this is an ongoing process. We're running this regularly, so we'd expect there to be purchase orders that have been placed but not yet received. So we're calculating the purchasing actions that need to be taken to meet demand. Now, the most obvious purchasing action are new purchase orders that we need to place. Many cases, we find that's where it stops. There's a bit of an overemphasis on generating new purchase orders. So we have a balanced 4-action approach to purchasing. Yes, there are purchase orders that we need to place, but so too there are orders that we need to chase. And this is material that is coming in. It's just not going to come in early enough. There are orders that we need to defer. It's coming in. It's got demand. But if it comes in at the current arrival date, it's going to sit around in our inventory a little bit too long. So maybe we can push that out. And then there's orders in there that we might not have any demand for at all. And those are the ones that we need to cancel. So we're discovering POs that have been placed but are no longer required.
We had an instance with a client in the States. We grabbed some of their data and shoved it through this sausage machine and presented the results as an initial opening presentation to the company, explaining, of course, that we need to go through the data and do a lot of cleanup and get this thing implemented properly. And at the point we showed a screen showing now, according to the data we have on hand right now, here's some orders we should cancel. Now, at that point, one of the buyers got up from his chair and left the boardroom. My initial response was he's being a bit impolite, walking away like that. And about a quarter of an hour later, he came back into the room and his boss asked him, what he was up to. And he said, well, look, I took a note of a couple of items that appeared on the screen. I went and checked, and yes, somebody had gone and changed the bill of materials. I did not have visibility of that. So I've just phoned the supplier. I managed to get in on time and cancel 2 orders, and we've just saved $20,000. Project paid for on the first day. So, yeah, it works.
Can't always promise to get those immediate benefits, but
sometimes
it's nice when that happens.
Place.
Yeah. So there's a question here in the chat from Roberto about DDMRP, and we've mentioned DDMRP. I think some of the principles that we have in place on replenishment and using replenishment to generate demand, feeding that into a more demand-driven system. We've developed a version of this planning system that goes beyond having some common principles and actually supports DDMRP all the way through to the naming convention, the color system that's put in the buffer calculations, calculating ADU and so forth. So it's a system that's very similar to this one, follows a process that is similar, but we've dotted the I's, crossed the T's on making it compatible with the naming conventions and a lot of the terminology that goes on within DDMRP. And we'll be offering a separate webinar where we'll go into that sort of, we'll use that system as an example. We'll go into that detail and show all of those DDMRP functions. So yeah, if you're on the list, we'll be sending out an invite to a webinar coming up, maybe later in the month or February, where we can talk about DDMRP.
Yeah, we have 12 live DDMRP implementations out there. Some large, some small. Every single one slightly different.
Yeah. Right. That we know of, right?
that we know of. Yeah.
Yes. Right. So again, refresh on where we are so far. We've gone through the distribution piece. We've determined what it is that we need to buy. So the last part of the puzzle are the things that we need to make. The output of the MRP module was items that we need to make. So we've exploded that through the bill of materials. Now let's have a look at the next along the line, which is capacity planning. So capacity planning and the following process and module, finance scheduling, are both answering the question of what do we need to make, how many and when, and what are the resources, the people, the machines, the time that we need in order to make it. So in other words, what is the required capacity? Capacity planning is very similar to people in APICS might understand the term rough cut capacity planning. It's a medium to long-term view, usually, where we're using offsets to allocate the load to days and weeks. So the inputs are the items that we need to make. We explode that against the process routing, which are all of the operations that are required to make the item, the standard time, the setup time, the work center that's required, and then calculating the load in hours and minutes of the work that's required for each of those work centers, and then putting it into a day or week using standard offsets. So this is a view where we're comparing load against available capacity for every day, week, and month. If we zoom in and have a little look at the details of this, so if we have a situation where the load hours, the blue, is way below capacity hours, the brown, then we've got excess or spare capacity, and this is capacity that can be taken up with new last-minute demand. If we have the blue above the brown, then it means we're out of capacity, and at this stage, that's a signal to go and do something. And logically, if we're out of capacity, there are only a limited number of things we can do. We can add units of resource. We can add people to the line. We can add machines. We can add units of time. So we can extend the shift through overtime or adding another shift. And if neither of those work out, we can move demand. Maybe we can pull that demand forward and have that item sit a little longer in inventory, but use spare capacity in the coming weeks. Or the last or worst case scenario, we can maybe push demand out if we know that we're not going to be able to make it anyway. So this is giving the information in order to respond to weeks where we can see into the future and we're looking at a crunch in capacity. In this particular example, we can see that demand is really ramping up through the middle of May onwards. So it really is time to extend the shift or to add another shift and to bump that standard time up. We can see that for the week of the 24th of April, somebody's already done that a little bit prematurely. So that might be a signal to cancel that overtime, or indeed to pull some of that demand forward. So this is at the range, usually at the range where people can react to adding capacity or shifting demand. And usually that's looking weeks out into the future. So the next step and final step within the process is finite scheduling. Finite scheduling, again, is taking that to make output from MRP. Again, taking the standards from the routing and the work centers. But now we're calculating a shorter term view. And very usually this is something looking out a week or two. We're now calculating the exact queue time and run time required and generating start and stop times for each job. The output is a standard Gantt chart output where every work center has a number of jobs that's cascading down from top left down to bottom right. And so too, we could take a view of this picture from the sales order or job instead and looking at all of the different operations that are cascading down. We want to be timing this so that we're using a pull logic. So the pull logic is calculating the latest start in order to meet our due dates. If that latest start happens to be in the past, we know that that's not going to be a feasible start. So in that case, we need a bit more logic to be able to understand what is the best schedule that we can achieve based on the orders that would otherwise start in the past. And a constraint here in finite scheduling is going to show up as an order being late. Again, not an ideal situation, but if you're out of capacity, there's nothing that a planning tool will do to magically add capacity. But that constraint is going to show up as a late order. But the important thing is for us to be able to know about it ahead of time so that we can, again, take action and maybe reprioritize or resequence those orders, do any last minute adjustments to capacity, or really use that information to make promises to the customer that we can actually keep.
Yeah, it's a three-pass scheduling algorithm. As Kian said, traditionally you'd look out for a fairly short horizon. However, if you're in a highly seasonal business, the three-pass scheduling algorithm can be extremely useful to present data to it for a much longer period. There's no reason why you shouldn't have a finite schedule for the entire year. And if you do that, what the three-pass logic is going to do for you is to suggest to you where or how early you need to start building inventory to ride over peak seasonal demand with limited capacity. I mean, an example of food companies we've worked for, as soon as the weather gets cold, people buy packet soup. They talk about soup season, and they don't have enough capacity to meet demand during soup season. So they have to build inventory in advance. The finite scheduling logic actually tells you, well, how far in advance you need to start building that inventory. Okay, there's a question about are we scheduling employees or are we scheduling equipment? That's a very relevant thing. And what we need to decide in setting up your capacity planning and your scheduling process is to say, well, what is a work center? Now, a work center can either be a chunk of machinery, a press or a packing line or something like that, and you schedule that, and you just assume that you're going to have enough people to man that line. Or you can do it the other way around and say, no, we are going to schedule people. Okay, so our work center will be a person or a team of people, and we are just going to assume that there's available machines for them and equipment for them to use. So we can do it both ways around. And of course, we have implemented versions of the system where we choose machines, for example, as the constraining resource, but we then apply some manpower planning on top of that and say, well, if you're going to run according to this schedule, I think you should know you're going to be 3 people short during that period. Maybe we need to reschedule to fit in to the available manning pattern that we have, or manning availability. So there's various ways of getting over that issue.
Yeah, but constraints-based planning, picking a single constraint for each of the work centers or operations, but also providing a lot more information about other constraints that might be needing some response.
Right.
Okay, other question. Does the system react to a PO or parts shortage or parts that are being late?
Mm-hmm. If I can answer that. Again, it is not an optimizer. You can't just bung at it. I have this material available, and I have this capacity available. And I have these people available. And I have these jigs and fittings. Throw that into a big pot and tell me what I can make with the material and people and capacity that I have. It isn't doing that. So generally what we do is to say, okay, here is a report we're gonna schedule to best use the capacity, and then here is a report that says, excuse me, here are some scheduled jobs which you are not going to be able to achieve because at the point in time that we want to build this item, we're not going to have the material. Okay, now you can either poke that at your purchasing people and say, go make a plan, fly the stuff in, find an alternative source of the material we wish to get the material in to respect the schedule. Or we say, okay, we're going to have to reschedule to respect the fact that we just won't have the material available. So it's a double-edged sword there.
Yeah. So if does this system react to a PO or part shortage being late? The system doesn't react, but it equips people to react and to make those options. When we've seen this work best, it is in combination with the intelligence that the people bring to the process. It's not a push button. Push the button, feed the information in, get the ideal answer. There is a lot of iteration. And I think this might speak to another of the questions. Can the system do scenario planning all the way through to purchasing? When the forecast changes or adjusting safety stock, some of those what if scenarios. And that's precisely a very good example of how people and the system can work together. So in many cases, we're not doing a single run and then acting on the results. We're doing a run with some expectations of what the right configuration might be, and having a look at the results. And then if that's good enough, then releasing it. If it's something that needs adjustment, then we go back, adjust, and run again.
Yeah, generally there are two copies of the system. The planner will have the live system that purchasing people and production people are responding to, and then an offline copy of the system for playing what ifs. And one of the typical what ifs is a available to promise type of thing. Is that if we here's a customer making an inquiry, if I give you this order, when would you be able to deliver it? So I'm not going to give you the order yet. I want to know what the answer is before I actually commit to that order. So that would be a typical what if, is that available to promise scenario.
Yeah, and that also speaks to Jason's question here about where you have alternative work centers that might have a different runtime. You know, and the way maybe we'd suggest handling that is, in order to do a run, we need to have a routing with a specific work center and a specific time for that item or that part to run on that work center. So we'd recommend having some primary work centers, but then run the system and see what the result is. And if we find that in the plan before we've executed it, in that what if scenario, we see that there's a work center overloaded, then the planner can go back and switch some of the orders to the alternative work center and then run it again. Yes. Now, over that iterative process, we should start to see an improvement. Things should start going in the right direction. So to be able to do a number of sort of what if calculations with different alternatives, those could be stock alternatives, they could be demand situations, or they could be capacity situations where we're moving jobs from one work center to another. And then being able to model that and see what the result would be before you make the decision to go forward. Yep. So yeah, we're getting some great questions here, and there's probably more than we can get to on this call. So what I'm going to do, maybe we'll come back to some of these, but I just want to show you all what might be a next step. So, you know, if you want to have a look at the integrated planning system, get to know it, what would be the step that you could take. So we've got the integrated planning system ready to download. Over here, you see it's a folder with a number of workbooks in it. Each of these workbooks performing one of the steps that we have just outlined. But they work in a flow. This master module is the only thing that you need to run in order to generate automatically these steps of the process, running all the way through until you get the final reports. So this folder is a full package of all of that information. It's currently populated with example data. It's a full set of data that we've created from a fictitious company, but implementing it would involve swapping that data out with data from your own system. So we've got a couple of webinars together with the download in order to make that happen. So the first one, setting up that input data, understanding the parameters, and working with this data interface module, which is the connection between the system and your system. And then the second webinar looking at running those modules, interpreting the reports and taking action. And these webinars are happening live next week, but they will be recorded. So it's available to view on demand and go through that content, either live with questions and again afterwards on demand. Now, there is an option here for a third webinar, which is looking with a smaller group, so we can be much more specific about what the situation of the people who are implementing it. And this is a small group for customizing and implementing the system. Okay, so three sets of webinars, and then maybe ongoing consulting support one-on-one if you need it.
If I can just say a word about our experience in implementing this system. We're often asked the question, as some of these questions are coming up, is but will it work for my business? And I begin to sound like a stuck record, because the first thing I say is, well, show me the data. Here is the input data that the system is going to require. Do you have this data available in your ERP system, and can we extract it? That's the first thing. And then to answer the question, will it work for my business? Well, let's see. Let's suck the data out of your ERP system. Sometimes that's a challenge. Sometimes it's very easy to do. Let's shove your data through the standard configuration of the system and see what comes out. At that point, we can start saying, well, to what degree do we need to customize and tweak the standard vanilla flavored system to fit your needs? But let's try putting your data through the standard system and see what pops out at the end. We're not guaranteeing, of course, that the standard system is going to solve everybody's problem. Most of the time, no, it isn't. But it's a very quick and easy way of assessing how well the standard will fit your needs, and then being able to define, right, these are the things we need to change in order to get it to fit your business. We've done a lot of tweaking and customization and additional modules and that sort of thing in the past to fit various situations. So questions like, but will it handle a make to order, or will it handle an engineer to order situation? Yes, it will, but we need to fully understand the shape of the data that we're going to feed into it.
Yeah, and this is usually a good exercise to be able to put the system through its paces, throw some real live data at it, and then start to see what sort of results. And in many cases that's been enough in order to improve those data inputs and get this system to running live, or at least in parallel with the existing process. So you take the next step of really putting it to work.
Yeah, it's a very flexible platform. It's an Excel-based system. It's very quick and easy to modify and change. So we're saying, look, rather than designing all your needs to the nth degree before you even start implementation, well, our recommendation is leap in the deep end and then figure out how to swim. Funnily enough, we're in a flexible enough environment to be able to use that experiential type of development process.
Yeah. So yeah, all of our like all of our tools, they're unlocked. We don't license the intellectual property. You can look inside the formulas. You can look inside the macros, and that folder has everything that you need in order to start running. So yeah, hope to see some of you next week in putting the system through its paces and working together on those webinars. So yeah, that's our hour. I think Tony, we could stay on a bit longer and look at some of the other questions.
Yep.
Let's see.
Will the system run on Excel for Mac? Yes, it will.
Have you done that?
Well, funnily enough, I've run live workshops many times, public workshops. I mean, walk into a room with your computer, 3-day type of things, and there's nearly always at least one or two people who've got a Mac, and in handing out the examples and working through the whole thing, the Mac people have somehow got it working. I'm no great expert in Mac at all, but Mac people do manage to get it working.
That's good to know. I've got a bit of a disclaimer on the page there that we've linked to, which said it doesn't support Mac OS, just because I think that there's a bit of rewiring required for the file file addresses.
Esoteric
There's no C drive.
Yes.
And I think you need a more recent version of Office for Mac, maybe past 2016, to support macros. Because so some of the old versions of Mac, Office for Mac just don't support VBA at all.
Right.
So yeah, yes, it will, with a health warning, and we'll happily help you work through that. Right. So. What should we take? System friendly for remanufacturing, where the BOM is 50% static and 50% dynamic.
Well, yes. You know, I was telling you giving you the example of the buyer who walked out of the room and cancelled some orders. That was a remanufacturing process. That was a remanufacturing company. So yes, we have had experience of putting it in that environment. Of course, there are a few tweaks and modifications and things like that. The BOM structure, of course, is dependent on the first part of the process, which is the disassembly and inspection. But certainly the company we worked with had some pretty good statistics that we could apply for planning purposes to say, 60% of that at the time the main bearing needs replacing. And we build that into the BOM structure for purchasing, etc. When it comes to the actual shorter term thing, where we're identifying a particular unit, and we know that no, the main bearing does not need replacing because we've just inspected it, then the shorter term planning would kick in at that point where we have better information. But upstream of that, we'd apply the statistical standards that have been generated over a period of time.
Yeah, and I think in the same vein, to answer Dee's question about custom manufacturing, there's a couple of ways of handling that. So if you're an engineer to order or a bespoke manufacturer where every order is different, we've got 2 or 3 different ways of handling that, and the simplest one would be to schedule based on a standard default or a family routing. So we're going to allocate it to a family routing, but having a pre-production step where somebody can really look at that order and be able to determine the actual flow of the process.
Well, my experience in that engineer to order situation is, if you learn to ask the question, okay, so a customer comes in with an inquiry, and you go through a process of putting together a quote, putting together an estimate of what it's going to take, materials and capacity wise, to come up with a quotation. So generally, there is some kind of quotation system in place. And then you ask the question, okay, well, what would it take to upgrade your quotation system to generate a BOM and routing for every single quotation that you come up with? And then when the order is accepted, you've already got the BOM and routing ready for slotting into the planning system. So that's for quite a few engineer to order people. We go and upscale their product configuration part of the process to be able to link into to the integrated planning.
Yeah, and in some cases, the configuration or the options that you choose can arithmetically calculate the amount of time that it takes to perform that process. In other areas, it needs some manual intervention to be able to interpret that information. But either way, there's then a building library of routing, so you're more likely to have the necessary routing the next time around.
Right, and that's one of the joys of actually working in something like Excel, because you can come up with rule-based BOMs and rule-based routings in those sort of engineer-to-order situations.
Yeah,
I mean, an example, we put the system in at PVC window manufacturing operation, where salesmen come in with with drawings and measurements, and every single product is different because it's made to measure for a particular building. It was big business in the UK at one stage, replacing all your windows with UPVC ones. Now the drawings, the drawing data or the spec data that the salesman came in with, which was basically all the specifications and the dimensions of each of the windows and doors. We managed to link into that and generate rule-based bombs and routings that flowed straight into the planning process. So yeah, it can be done, and it's much easier to do in an Excel type of environment than some heavier customization.
Great. Okay, so Tony, I think we have to leave it there.
Yep.
We could in previous webinars stayed on until the last attendee leaves the room, but let's respect people's times. What I will say is that we've got questions here that we haven't yet got to, and apologize for not getting to your question. I will make sure that we provide you with an answer by email. And we're also going to be putting together a Q&A webinar sometime next week, where we can gather together some of the questions that require a little bit more depth in the answer. And we'll put them all together in one webinar and answer them one by one. So you'll get an invite for that. And we'll quite happily answer any further questions that you might have coming through email. So great. Thanks very much, everybody, for joining us. We know that there's a lot of competing demands for your time and a lot of information events out there. So we appreciate you giving an hour to us. And we hope you've enjoyed it. Please give us some good feedback. Give us some bad feedback if that's what you have. We'd really like to know how it comes across and where we should be pitching this kind of content. So if you've got any suggestions for the future, then please let us know. So in the meantime, it's goodbye from me.
And goodbye from me. And it's so great to see familiar names, old friends coming up on the list of attendees. Very heartwarming. Good to see you again. Ciao.
Okay.
Bye.
And look forward to seeing some of you soon on a webinar coming up. Thanks very much.
Okay. Goodbye.
Bye.